Hello, sir.
Yes, Ravindra, you are audible now. Clear.
Yeah, actually, because of that net issue, I got disconnected. Hmm.
Okay,
So,
okay.
yeah. I hope the screen is visible. Hello, I hope the screen is visible now.
Yeah, please go ahead. We can go ahead because I think now it has got stabilized.
Yeah, yeah. Okay. Okay, then, welcome everyone. This is the Polymer Reaction Engineering Session 6. We'll be going through a few questions which will help you to solve your assignment number 6. Today's class will include mostly the processing of the polymers and the different parameters involved in the different kinds of polymer processing. So the first question is, the termination in the ionic chain polymerization can be perceived through, we have three options here: recombination of counter ions, formation of a sterically hindered ion having broad charge distribution, forming a sterically hindered ion having very narrow charge distribution. So here you can see that there is a reaction scheme given here, where there are the three steps of initiation, propagation, and termination. So for ionic chain polymerization, again, it is proceeding in the same way as a chain group polymerization with a which radical ion, which initiates the reaction and proceeds, propagates the entire monomer and terminates after recombination of ion, the recombination of the radical. Now that is for the chain group polymerization, but in this case, the recombination will occur because of the counter ions. So the first option, that is recombination of counter ions, is the correct answer for this. In the next one, it has been given that for forming a sterically hindered ion having broad charge distribution. Now, broad charge distribution can occur only when the charges are scattered throughout the polymeric chain, and this will only occur when the end groups of a chain which are having the opposite charges combined together, which will form the sterically hindered broad charge distribution. So you can see here that there is a charge group of Pn and Pn star and Pn dot. So these two, when they combine together, it will form the Pn plus n chain plus the Pn minus plus Pn edge. So these two, when they combine together, they form a sterically hindered ion having a broad charge distribution. So that's how they separate outside in the termination step, as you can see right here. So these two are the ways through which a ionic chain polymerization terminates. So I, I hope this part is clear to you that the Pn dot right here plus the Pn dot, when they combine together, at the final step of the termination. They form together a Pn plus N polymer with a sterically hindered ion having a broad charge distribution of Pn minus plus Pn positive right here. So that is the ion of the broad charge distribution. Moving on, in radical chain polymerization, the term dead polymer signifies what? So the formation of unwanted polymer, the cessation of the growth of initiator, the cessation of growth of propagating radical, or all of these. So in radical chain polymerization, again we have a initiator which propagates forward to form the polymer chain. So in this case, unwanted polymer is out of the question because if we are trying to focus the radical polymerization for a single polymer, that will be the that will be the main focus of the process. So formation of unwanted polymer does not signify the term dead polymer. Dead polymer occurs when the uh, growth of the propagating radical is stopped. Growth of the propagating radical is stopped when the radical chain is like coming together to combine recombination of the radical itself. When we have, for example, we saw in the previous example, in the previous example right here, we saw that in the termination step, there were two polymeric chains with Pn plus Pn. When they came together, these both chains terminated the entire reaction. So similar thing will happen here in the radical chain polymerization also. That when two polymer chains, when they come together, the opposite uh, charges, when they are coming together, in that case, even if you introduce a large amount of monomer, that reaction is not going to proceed because the entire chain, the end groups of the entire chain are stabilized and they have no more room for reaction, further reaction. Since there is no more room for further reaction, that polymer chain will remain dead. Dead in the sense like it has become a stable radical or a dormant species. So it becomes a dormant polymer and it is not going to propagate any further. So the cessation of the growth of the propagating radical is what is called a dead polymer. Since the final dormant polymer is not going to propagate any further, it will show the stopping of the growth of the propagating radical is the correct answer for the dead polymer. That is the option third. Moving on to the next question. Which among the following options will show the highest positive resonance effect plus R effect? Now, first of all, resonance effect or the mesomeric effect uh, can occur of two types, that is the positive and negative. In positive resonance effect, what happens is any species which is having more number of electrons or which is a nucleophile, which can donate a few of the electrons to uh, the subsequent species, the main the main species. This substituent group can donate the electrons to the main species, and that creates a resonance effect because of the polarity. Since it is having a negative charge and it is donating the electron to the main body, so that creates a positive resonance effect. So among these, which will show the highest positive resonance effect. So there is a particular order for the resonance of the species, and we can clearly see here that fluorine and chlorine here have been shown without any lone pair or the negative charges not there. So here we can see that OH minus, negative NO2, and the Cn are the ones which are shown here. So minus OH shows the highest positive resonance effect, which is following a particular order of the resonance effect for the different species. So this effect goes from OH showing the highest, followed by the Cn group, then NO2, and at last chlorine and chlorine. So OH minus is showing the highest positive resonance effect. Which of the following are not the characteristics of the chain growth polymers? So it has asked us to show which are not the characteristics of the chain growth polymer process. The first is high molecular weight polymer formation. using unsaturated monomers. This is the basis of the chain reaction process, so it is slow. Second, bifunctional or multifunctional monomers forms higher molecular weight chain polymers. Now, this statement is false because having multiple functionality on a monomer does not ensure high molecular weight chain of a polymer. Why? Because multiple functionality does not mean that the chain itself is increasing in length. Multiple functionality can result in high degree of cross-linking, or the bifunctionality can show that high degree of cross-linking or branching can occur. So that's why high molecular weight of the species is not ensured because of the bifunctional or the multifunctional nature of the monomer. So this statement is false. Third is initiators are required to start the reaction, which is true for the chain of polymers. And fourth is propagation occurs till the end of monomers without termination. Now, this is not the case for chain of polymers because propagation occurs till the end of monomers without termination is not true. As we have seen in the previous question, that there is something called a dead polymer. So if we reach a stage of the dead polymer, then the entire propagation will halt even if the monomers are remaining there because there are no reactive groups left to react further. So the propagation occurs till the end of monomers without termination is the false one. So bifunctionality and propagation occur until monomer till end of monomers. These two statements are false in case of chain growth polymers, chain growth polymers and chain growth polymerization process. Moderate polarity solvents are preferable in ionic polymerization because we have a blank there. The preferable solvent as per their polarity can be another blank. We have to choose the correct options. So we have been asked two questions right here. So we will go through them one by one. First is moderate polarity solvents are preferable in ionic polymerization because. So what is the reasons we are using the moderate polarity solvents? First statement is high polarity solvents can make the stable complex or completely kill the initiators. Second is high polarity solvents can accelerate the propagation to such an extent that the desired molecular weight polymer formation will be uncontrollable. Now, among these two statements, the first one says that high polarity solvents can make stable complex or completely kill the reaction is the correct one. Why? Because in high polarity solvents, when it initiates the reaction, it is very good for initiating the reaction and it accelerates the propagation at a fast pace. But once the propagation starts, the extreme polarity difference which is created because of the high polarity initiator and the propagated material, propagated species is very different. And because of this, the molecular weight polymer formation is not controllable in that aspect. So that's why high polarity solvents can make complexes or completely kill the initiator is the correct option because it will kill the initiator in the sense like the polarity difference will be very high and the propagating species will be much different from the initiator species if the high polarity solvents accelerate the initiation process rapidly. So because of that, moderate polarity solvents are more preferable in ionic polymerization. So for the first plan, the first line, first option is the correct one. The preferable solvent as per their polarity can be dash. So we can clearly see that there are two solvents given here, water and ethylene dichloride. So which one will be the correct one for this is since water is a highly polar solvent, ethylene dichloride is the correct answer for that. So that's why it's a preferable solvent since we are asked to since the correct statement is that moderate polarity solvents are suitable for ionic polymerization. That's why ethylene dichloride is the correct answer for this one. Next we have nitriles are the electron withdrawing functional groups and can decrease the electron density over the carbon-carbon double bond, resulting in development of partial positive charge over the carbon atom and hence such monomers are facilitated by. So it has been already given that the electron withdrawing functional groups can decrease the electron density over the carbon-carbon double bond. So we are already seeing that there is electron withdrawing functional groups are involved because of the nitriles. So we can see that it's a ionic polymerization process going on. So on top of that, in development of partial positive charge over the carbon atom, and hence such polymers are facilitated by that. So since we are talking about the positive polymerization process, so it is quite easily understood that an ionic chain polymerization process is being talked about right here. So that's why the correct answer for this one is the anionic chain growth polymerization process. Next we have an engineer is wishing to develop a high molecular weight polymer with lesser reaction time. Which of the following types of polymerization processes should be used? Chain polymerization, stable polymerization, polycondensation, or the ionic polymerization process. So in this case, we can clearly first of all rule out the polycondensation option because condensation polymerization is the name of the process and polycondensation is just a phenomenon which is occurring in that aspect. So we have three options effectively, that is chain polymerization, stable polymerization, and ionic polymerization. So here, the nature of the chain polymerization process and the ionic polymerization process, what does it tell us is, in chain polymerization process, we have a radical which starts with the reactive species and it propagates to give a high molecular weight product. And how does that happen is, single monomers are coming together to form a larger chain. In step-load polymerization process, what happens is that the propagating species is doubled with every reaction step. Now, this can look like the high molecular weight polymer is achieved in a lesser reaction time, but the possibility of having a dead polymer or the recombination of the end groups is much higher in the stable polymerization process. And that's why chain polymerization process and ionic polymerization process are much more suitable for development of a high molecular weight polymer with lesser reaction time. That's why the correct answer for this question is chain polymerization and the ionic polymerization process. Since these both are similar in nature and they both proceed with the same reaction mechanism, just only in different forms. One is in for the ionic polymers, and one is for the normal polymers going through the chain growth process. Now we have a true or false question. Statement one: isorigid polymers have unique head-tail placement, while arigid polymers compose of random head-tail and head-head placements. Isorigid polymers have unique head-tail placements, while arigid polymers compose of random head-tail and head-head placements. In statement 2 is syndiorigid polymers compose of alternating head-tail and head-head placement. Choose the correct option. So, in the previous few classes, back few classes, we have already seen the tacticity of the polymers, and I have already explained about the isotactic, atactic, and the syndiotactic natures of the polymers, where the head-tail placements have been discussed. Now, in head-tail placements, you can clearly tell that the arrangement of the functional groups on the backbone of the polymer is what is defined through the isorigid, arigid, and syndiorigid in these statements. So, the head-tail placements uh, we can see that a unique head-tail placement is followed in isorigid and arigid polymers composed of random head-tail and semi-rigid polymers have the alternating head-tail and head placement. So the statement 1 is true and statement 2 is also true. So this is from the direct definition of the practicity of the polymers and the isorigid, arigid and semi-rigid follow the same nomenclature and because of that statement 1 and statement 2 both are true. During radical chain polymerization, operating temperature possesses moderate but positive effect on increasing the degree of head-to-head placement of vinylic groups. So this is an effect which has been observed in the chain polymerization of vinyl groups, where that the increase in temperature possesses a moderate but positive effect on increasing the degree of the head-to-head placement of vinyl groups. Why does this happen? Is because as the temperature increases, and since the vinyl groups are thermoplastic in nature, the arrangement of the head-to-head placement of the groups is quite isolated in nature. Because of that, they both uh, the different vinyl groups are present on the same side with the head-to-head arrangement, and because of that, the arrangement is like moderately controlled by the temperature, operating temperature. That's why the placement of the head-to-head groups of the vinyl monomers are true. So that's why the statement is true. Electron band functional groups like another one increases the electron density over the carbon double bond of the system. This leads to facilitate the cationic polymerization of the monomer. Now, in the previous question itself, we have already understood that uh, among the four options right here, nitrile groups are contributing to the cationic polymerization process. So here again, after reading the question statement, you can see that electron density is increasing over the carbon-carbon double bond, which means that the species is donating the electron pairs to the carbon-carbon double bond. So we can see that the options which match this reduction is that first one is electron donating functional groups. So the first blank should be donating functional groups like, and since there are only two groups given right here, nitriles participate in the cationic anionic polymerization process. For the cationic polymerization process, we have the alkoxy group. So electron donating functional groups like the alkoxy increases the electron density over carbon-carbon double bond of the system. This leads to facilitate the cationic polymerization of the monomer. So option B is the correct answer. So today's class was basically only theory based, that only the basics of the processes of like a chain growth polymerization, step growth polymerization, and polymerization were discussed right here. So I don't think you should be able to have any doubts on this, because most of sir's notes will be clearing you upon all of these questions. So if you follow all of these, it's very easy for you to know this. And this is already present in the notes. So I think
That is
should,
that
uh,
is the reason actually we are keeping quiet. Anyway, this is a good information. It will be
yeah,
useful
yeah.
to reflect.
Hmm. Yes, yes, that's why. Actually, like the previous few sessions were quite heavy on the reactor design and how the reaction scheme is proceeding. So that was like much more important topics. I mean, I would say that more important topics have already been discussed, and from now onwards, I think it will be more based on the process parameters of each polymerization process. So yeah, that's how the course will proceed from here. I think Partha has joined a bit late, so if you want, I can just go through the first few questions again, or else if you want, you can.
Yeah, that would be nice if you can like go through well, in a speeded manner. If you like,
Yeah, yeah. Okay, I'll just go through the first few questions. Okay, so here we have been given first first question is the termination in ionic chain polymerization can proceed through the following options. Choose the correct option from this. So we have been given first is recombination of counter ions. Then next we have forming a sterically hindered ion having broad charge distribution. So Or third one is forming a sterically hindered ion having very narrow charge distribution. So going from options one by one. In first one, we have the recombination of counter ions. When the recombination of counter ions occur, which means that if a polymer chain is there, and if counter ions are coming into picture, that is, if the one end is having a positive ion and it comes into contact with the negative one, it will the reaction will terminate right there. So that is one method for the polymerization to terminate. So recombination of counter ions is the correct one. That is the first one. Second one is when the formation of a sterically hindered ion occurs. When is this happening? Is you can see in the reaction scheme right here that when the termination process is encountered, uh, you can see that Pn dot plus Pn dot is combining together and it forms a polymer of Pn plus 1 with an of ion of Pn minus plus Pn plus. So this ion formation is having a broad charge distribution. Because of a broad charge distribution, the reaction is the ion is sterically hindered and it won't undergo any more further polymerization process because the charge distribution is very broad. If it was quite narrow, it would have, because of the different polarities, it would have again started the polymerization process. But since the hindered ion is having a very broad charge distribution, it has become stable and it won't react any further. That's why termination of ionic chain polymerization occurs by either recombination of counter ions or second, formation of a sterically hindered ion having broad charge distribution. Second one is in radical chain polymerization, the term dead polymer signifies what? Same like the ionic chain polymerization. In radical chain polymerization, what happens is when is a dead polymer formed? What is a dead polymer? First of all, the definition of a dead polymer is a polymer which cannot react anymore further and which will not grow anymore further, which means that it has gone dormant. So here you can see that here in the reaction schematic, you can see that a dead polymer is a polymer which is like if it recombines with the ions, it won't be able to grow anymore further. So even if you add any more monomers into it, it won't react because the end groups are saturated. So because of that, a dead polymer is formed. So this happens when the cessation of growth of the propagating radical occurs. Since the propagating cell, as the polymer is increasing and going forward, if the end groups get saturated either due to some kind of counter ion coming into picture or because of some other imbalance, because of this, the propagating radical stops growing and a dead polymer is formed. So no matter how many radicals you add, how many radicals or monomers you add, this dead polymer is saturated and it won't go any further. That's why the third option is the correct one for us. Next we have which among the following.
Can I ask, just as a query? These
Yes.
questions are based on the topics which has been given in the week 6, or it is related to something other topics?
No, no, it is for week 6 and for the further weeks also.
Week, like it is also taken something from the week 7 also.
Yeah, because from the previous week's questions were based on reactors, right? From this week onwards, it is based on the polymer reaction processes. If you have
Okay,
gone
actually,
through the
I didn't start week 7 lectures actually. That's why
oh
I finding it little bit of out of syllabus thing for me.
oh okay.
Mm,
So
mm.
one thing you can
I think
do
it is
these.
recently it is published. I think week 7 is
Hmm,
I think yesterday or day before yesterday it's been published.
yeah. Since my class is on Tuesday and the material is getting published on Monday, I'm just keeping some questions updated so that if you want, you can just revisit this and you can take a look at this. Right? It's something like that.
Okay. So
Hmm.
there is a term that dead polymer.
Hmm.
So it is something related to the polymer which is condensed as a byproduct we are getting that
It's a
that part or the termination thing we are
it's a termination thing
talking
actually.
about.
It's a termination thing. So when the propagating radical in this diagram also you can see P and dot is there. So when the
I
propagating
mean, it is the
radical,
threshold level where the polymer won't reaction itself and it is terminated. That
yeah,
state it is known as dead polymer.
yeah, exactly. It reaches that point and it stops reacting further. It terminates. That is the dead point.
The state after the termination of the polymer it's known as dead
Yeah,
polymer.
yeah, yeah, exactly. Uh, if you are having difficulty in understanding any of these, what you can do is go through the week 7 lectures and then you can revisit this lecture on YouTube because all these videos will be posted on YouTube. So you can do
Okay, okay. That will do.
that. That will be much more helpful for you because even if I tell you this right now, you will be able to understand this much better if you study it from search notes because there it will be written directly.
Actually, the issue with me is that I'm from different background actually.
Hmm.
Like Savana sir already know
Hmm.
कि I'm my background is mechanical and
Okay.
as I've taken admission part-time PhD from IIT Roorkee in chemical engineering department
Yeah.
and there I've taken this NPTEL course as my coursework. So for
Okay.
me, entire thing is new for me,
Hmm.
and I'm just trying to cope up with the syllabus and everything, and get as much conceptual thing as much I
Hmm.
can get.
Okay.
So sometimes the question whichever I'm asking may sound
Huh.
little silly or maybe sounds little bit of easy thing or little bit more into conceptual or like that.
Hmm. Hmm. Hmm.
So for that I will be sorry for that, but I'll be like uh,
No, no, no. It's not that. It's not that. I think that you will be able to understand Sir's explanation much better than mine is because here I'm only discussing one single question. Sir is discussing the entire topic there.
yeah,
So
yeah.
that will
Actually,
be,
I
yeah,
was when I go through the lectures, sir is
yeah,
explaining.
hmm,
Definitely, that is beneficial. But
yeah,
live lecture is, I think, it is more effective
hmm,
because in my coursework it is mentioned I can take only one NPTEL course. That's why I've taken because of my work passion and all. But
yeah,
what I find ki, if the course or anything which is live where I
hmm,
can able to ask because
yeah,
there is a possibility then definitely there will be confusion.
yes,
So
yes,
that one I get the advantage by attending your lecture and one lecture that I've like Monday Tuesday lectures. So I generally don't miss it. So
okay, yeah, yeah,
mm,
okay, okay, that's fine, no problem.
mm.
So it's okay. So we have here. Which of the following are not the characteristics of the chain growth polymers? So we have already, I think you already know what is the chain growth polymerization process. So let's go through the options one by one. First is high molecular weight polymer formation using the unsaturated monomers. So this is the basis of chain growth polymers. We like make the unsaturated monomers join together one by one to form a long chain, which is the high molecular weight polymer formation. So that is the characteristics of the chain bond polymer process. So this is not the correct answer for this because we are asked to find the points which are not the characteristics. Second one is bifunctional or multifunctional monomers form higher molecular weight chain bond. Now, what happens with the bifunctional or multifunctional monomers is that it's not necessarily guaranteed that it will form a high molecular weight polymer. Why? Because during multiple functionality of a monomer, it is it is observed that it will either go into cross-linking mode or form much more branching because multifunctional monomers won't necessarily increase the chain length, but they will make the polymer more spread out. And that is because there are different. active sites on the monomer itself. So it can either increase the chain length or it can spread out the chain itself. So spreading of the chain can occur since the monomer is not exactly propagating from one point onwards. That's why this statement is not exactly characteristic of the chain growth polymer. Since the chain growth polymers, what happens is the chain goes one by one, going from a single monomer to the next, to the next, to the next. So multiple functionality monomers don't necessarily guarantee higher molecular weight chain polymer. So this option is the correct one for this. Third is initiators are required to start the reaction. This is a quite basic uh, concept for that initiators are definitely required to start the reaction. That is correct. The fourth one is propagation occurs till the end of monomers without termination. Now this is not the characteristic of chain group one. Why? Because propagation occurs till the end of monomers without termination. Now this can not be true because as we have seen in the previous question itself, that if there is a formation of the dead polymer. So if the dead polymer forms, no matter how many monomers are left, they won't propagate anymore. That's why propagation till the end of monomers is not true for chain group polymer. So options 2 and 4 are the are not the characteristics of chain group polymers, and they are the correct answer from this question. Then we have fill in the blanks here. Moderate polarity solvents are preferable in ionic polymerization because blank. The next point is the preferable solvent as per their polarity can be blank. Choose the correct options. So in moderate polarity solvents are preferable in ionic polymerization. First of all, the reason for choosing moderate polarity solvents is that when we are using high polarity solvents, high polarity solvents create a disbalance and they initiate the initiation of the reaction is very fast because of high polarity solvents. But since the high polarity solvents initiate the reaction faster, the initiated reactions can cause a mismatch with the propagating step. Since the polarity difference is very high, because of the initiator having high polarity and the propagating material having somewhat moderate polarity. So that kind of uh, instability can cause the high polarity solvents to make stable complex or some kind of like it will completely shut the initiator. So that's why high polarity solvents can make stable complex or completely kill the initiators. And that's the exact reason why moderate polarity solvents are preferred in ionic polymerization process. And second option is second the part of the statement is the preferable solvent as per their polarity can be. So we have been given two solvents right here, the options water and ethylene dichloride. We know that water is a highly polar solvent, and from the previous statement, we can see that moderate polarity solvents are much more preferred. Ethylene dichloride is a moderately polar solvent, and which is much more suitable for the process of ionic polymerization. Nitrides are the electron withdrawing functional groups and can decrease the electron density over the carbon-carbon double bond, resulting.
In the previous question, sorry to interrupt. In the previous
Yeah,
question,
yes.
there is a blank,
Hmm.
two blanks.
Yeah,
So
yeah,
options are
the
four. There are four
yeah,
numbers of options.
yeah. The first blank is the first option, and the second blank is the fourth option.
Okay.
Yeah.
Okay.
Okay. Uh, Next we have the nitrides are the electron withdrawing functional groups and can decrease the electron density over the carbon-carbon double bond, resulting in development of a partial positive charge over the carbon atom, and hence such monomers are facilitated by. So these monomers which are having a positive charge over the carbon atom because of these specific groups are definitely you can see that this is a ionic activity. So this is a ionic chain group polymerization process, And since there is the production of the partial positive charge, the correct answer for this is the anionic chain core polymerization. So the nitride groups are involved in the formation of partial positive charge. So that's why it is an ionic chain core polymerization process. So this is a quite straightforward answer for this question. Not going into too much depth about this because it is quite self-explanatory, I would say. That not much technicality is asked, only the charge distribution, what kind of charge distribution is occurring over the carbon atom is being shown here. And nitriles produce positive charge over the carbon atom, so it's an ionic chain group polymerization. That is the first option. Next we have is an engineer is wishing to develop a high molecular weight polymer with lesser reaction time. Which of the following types of polymerization process should be used? So we have four processes here, and you can see that the third one is written as polycondensation. Polycondensation is a phenomenon which occurs during the condensation polymerization. So we can rule that out because it's not a polymerization process. So effectively, we have three processes there: chain polymerization, step growth, and ionic polymerization. So again, in the step growth polymerization process, what are the things which can occur is in step growth polymerization process, the propagating chain doubles in size as the step grows, or with each step, the propagating chain doubles in size. Now, what are the disadvantages of this is that it can facilitate the formation of a dead polymer much more quickly than the chain polymerization or the ionic polymerization process. So that's why step growth polymerization might not be favored for the production of a very high molecular weight polymer. It will definitely give you lesser reaction time, but insurance of a high molecular weight cannot be said for the same. That's why chain polymerization process is much more accepted and much more used for creating high molecular weight process because it's a pretty simple process where we are increasing the monomer one by one and increasing the chain in a straight line. So the possibility of creation of high molecular weight polymer is much better in chain polymerization. And the ionic version of that is nothing but your ionic polymerization. So both chain polymerization and ionic polymerization are the best options to create a high molecular weight polymer with lesser reaction time.
Rahulji, one small
Uh,
request. There is
Yeah.
one
what?
more.
Yeah.
Sorry, Parthaji. Actually, there is one
Yeah.
more parallel
No, no,
session
no, no.
for me
This
in
is
RM. Shall I take leave if you don't mind, so that
Y-
I can
Yeah, yeah,
continue
yeah,
on?
sir. Definitely, sir. Definitely. You can take
Sorry
leave.
for that, and thank you very much for the class, because
Yes.
that was like one RM course which was like a parallel session. It happened. That's why, unfortunately,
Okay.
late has come, and this is
Definitely.
the first
Okay.
session. That's why.
Okay, sir.
Thank you very much, sir. Thank you,
Yes. Okay.
Parthaji. Please go ahead.
Yes. Yes. Okay.
actually, sir, I have a question actually.
Yeah.
Uh, in this question, like you mentioned, mm, in lesser reaction time,
Hmm.
uh, an engineer is wishing to develop a high molecular weight polymer. So,
Hmm.
polycondensation can also be considered in this type.
Condensation polymerization can be considered. Yes, it can do that. But that will be it will be more like there will be always condensation of water and we'll have to remove it because it will be causing some heat transfer problems in
Yeah,
the.
some kind of byproduct will be eliminated
Yes, yes,
every time,
yes.
like kind of ammonia or water.
Hmm. Yes, that is hard. So the easier way or the straightforward way for the creation of high molecular weight is chain polymerization. So that's why that is the preferred process.
Okay.
Yeah. So I think we reached this point where you joined the class. I think this was the question,
Yeah,
right?
yeah,
Yeah.
yeah, yeah.
So yes, so we have discussed the questions from that point, and you have already seen these questions. And if you want to revisit this lecture, this will be uploaded on YouTube again, so you can go through that.
Yeah, there are total of how many questions, sir, in
Uh,
this?
yeah, that's it. 9, 10, 10 questions are there. So, yes, there are only 10 questions there.
Okay.
Hmm. Yes. So, like, if you have any
So
doubts, huh?
these 10 questions only, na, sir?
Yes, yes.
Okay, okay.
Are you doing any other NPTEL course or only this one?
Actually, I have taken in this semester this NPTEL course,
Hmm.
Polymer Reaction Engineering,
Hmm.
and in the next semester I will be taking. Actually, there are core subject that I have to supposed to take. So
Okay.
that I will be taking offline as per
Hmm.
the protocol and rule regulation from the institute.
Okay. Okay.
And as far as my background is concerned, this polymer reaction engineering is not my already I didn't have this in my curriculum before.
Hmm.
It's a
Yes.
mechanical background as as you already know.
Yes. Yes.
And actually, the place I am working is related to polymers, plastics actually. I'm working in
Plastics.
CPET.
SIPET.
CPET.
Oh, okay. Okay.
Yeah,
Okay.
I'm working here as a technical officer in
Hmm.
CPET.
Okay.
So already, I'm doing work related to mechanical like mold, dyes and plastic testing,
Hmm. Hmm. Hmm.
processing
Yeah. Yeah.
and design, all these things.
Uh,
So I have motive on choosing this particular subject is that I want to do further research on polymer composite,
composite. Okay.
plastic polymer composite, and more into sustainability like plastic waste.
Hmm. Hmm. Hmm.
So my motive is to take that. That's why I've taken related subject this one, which I which I'm thinking which will be beneficial for me.
Okay.
So during as the days going,
Hmm.
uh, I'm trying to like get more into this each like topics and getting myself clear.
Okay. Okay.
It is more into reaction, so uh, it is not exactly related to the field I'm already working or reading or learning.
Okay.
So
One suggestion that if you want to go for sustainability, I suggest
yeah,
that you go into formation of thermoplastic composites.
thermoplastic. Yeah, yeah.
Yeah, thermoplastic composites because they are very easy to recycle because since they are easily molded under temperature, you can go for thermoplastic composites.
Yeah,
Hmm.
yeah, exactly. Yeah, thermoplastic, there are several products, and
Mhm.
already we are doing this processing of thermoplastic polymers only, like PP, PC,
Yeah, yeah.
PS,
PS, correct.
yeah, and LD, HDP pipes also there.
Hmm.
So I'm my interest also in that only.
Okay. Actually, my work, which I am doing here in my PhD, also is related to polymers only, and I am also working with ultra high molecular weight polyethylene. So that and another thermoplastic composite of polyethylene I'm working. So I'm also working in that field.
Okay, okay, okay. So high molecular weight is there is any benefit of this high molecular weight polymers?
Yeah, one big benefit is that the properties are much better. Like in my application, which I am focusing, it's based on the mechanical properties of the polymer. And if you know about the polymer processing and how it is done, you can clearly tell that higher molecular weight will actually give you much better properties,
Okay, okay. Means
mechanical
high molecular
properties.
weight is eventually indicating high density of the polymer, right?
Yes, exactly. No, actually, not. It's not actually that like that because HDP is having a much higher density than the ultra high molecular weight polyethylene.
Okay.
The reason why that is happening is HDP chains are long, but they are not too long because when they're long, they can pack together very easily and they can become dense. But ultra high molecular weight polyethylene is having very high molecular weight, like in the order of millions, 2-3 million units, like that. So what happens with this extremely long chain is that there is sometimes entanglement, and because of entanglement, the packing of the chains is not happening that efficiently like in HDP. So because of that, the density of ultra high molecular weight polyethylene is slightly lower than HDP. But the strength of ultra high molecular weight polyethylene is much higher than HDP.
Okay. Strength, like
Hmm.
other properties.
Yes, exactly. Other properties. And that is mainly dependent on the processing of the polymer. So if you are like making the fibers out fibers, right? If you are doing something like what should I say now? If you have a molten polymer and if you're cooling it down and if the cooling rate is slow enough, the crystallinity of the polymer will be high. And because of the fact that crystallinity is very high, it means that the polymer chains have densely packed together, increasing the
Okay.
mechanical property.
Okay.
Yeah,
High molecular weight doesn't mean it should have high density, but the
huh,
molecules will be densely packed and it will result in good properties of the polymer.
polymer. Yes, exactly. Correct. So you are also working on molding also, right? Molding and
Yeah,
other
yeah,
things.
yeah. Actually, I'm in Tulum department.